Hi, this is Fatima Tijent, a PhD student at International University of Rabat. I'm working on reliability and thermal management optimization of gallium nitride-based devices and their applications. This work is supervised by Professors Mustapha, Faqir, Hajar, Chouiyakh, and Paul Voss. During this presentation, I'm going first to present what is the problem we are trying to figure out in this research study, what are the main achievements that have been done so far, and the results obtained during the study. Finally, I'm going to finish this presentation by a conclusion. So as we know, power electronic devices are used to control and convert electrical energy. And most of electronic devices used today are based on silicon. However, these devices have reached their limits in terms of breakdown voltage and on-state resistance, which require to look for other solutions. One of the promising solutions is gallium nitride HEMT, which stands for High Electron Mobility Transistor. Because of its unique properties, such as high breakdown voltage, low on-state resistance, high electron velocity, and mobility, this device is considered desirable and suitable for high frequency and high power applications. Gallium nitride HEMT, as we can see from the figure at the right, is obtained by joining together two different materials, gallium nitride and aluminium gallium nitride, and this results in the formation of a two-dimensional electron gaze channel at the interface because of spontaneous and piezoelectric polarization effects and uses in these both materials. Despite the advantages of this device, there are some challenges that hinders its operation at its maximum potential. These challenges are basically related to thermal management issues. Because of the large lattice mismatch between gallium nitride and available growth substrate, for example, silicon carbide, silicon, or sapphire, a high dislocation density is induced. In addition, these substrates, they have a low thermal conductivity, which results in what is known as self-heating effects. These two effects give birth to a poor and bad thermal management, which degrades the reliability and lifetime of gallium nitride HEMT. In this regard, our objective is to develop and find a suitable solution that will address these issues. For the work that have been done so far, it's basically a literature review about the different and various solutions that have been reported in literature to address the aforementioned issues of gallium nitride HEMT, in addition to an analytical model in order to determine the influence of different parameters included in this model on the device performance, especially its electrical properties. For the results obtained using this model, as we can see at the left, the graph shows the variation of polarization charge as function of aluminium concentration in aluminium gallium nitride layer. As we can see, the polarization charge induced at the interface of gallium nitride and aluminium gallium nitride, it is positive, and it is increasing with the increase of aluminium molar fraction. The second graph shows the variation of carriers concentration as function of the voltage applied on the gate. It is also increasing with the increase of Vg. Finally, the final graph shows the variation of Ns, which is the carrier's density, but this time is function of aluminium molar fraction. It is also increasing with the increase of aluminium concentration. So these results have been done in order to determine later the variation of the drain current that is flowing in gallium nitride HEMT device. Finally, gallium nitride HEMT is considered as a switchable and a promising device for high power and high frequency applications, for example, for converters and inverters used either in electric vehicles or in PV technology. But because of thermal management and reliability issues, this device is not used in its optimal potential, which requires to find switchable solutions that will address these issues and improve its performance. So that's it, and thank you for your attention.